Mysteries of flight. Takeoff. Imagine you are walking down a narrow aisle. A short row of seats lies on either side of you. With three seats on each side, everyone around you is stuffing luggage into large compartments overhead, or they're pushing things on their seats. You do the same, and then you scoot into your seat and buckle your seatbelt. You continue to look around. You notice that the walls curved up toward the ceiling. The small plastic window beside you has a 6 shade that you can lift and lower. People continue to walk down the aisle with more and more luggage. And suddenly you wonder, how is this big heavy metal tube with all these people and all their stuff ever going to get off the ground? What you're really asking is, how does an airplane fly? Throughout history, the question of how to fly or how to soar through the sky like a bird has intrigued and mystified people. After all, if birds can fly, why not humans? Some people even made wings that resembled those birds, and attached them to their arms. Flapping their arms wildly, they soon discovered that homemade wings were not the key to human flight. Then, in 1783, someone found a way to fly. In that year, two brothers in France figured out that hot air was lighter than cooler air. If they filled a giant balloon with hot air, the warmer air inside the balloon would rise above the cooler air surrounding it. Ingenious. With this discovery, the brothers proceeded to create the first hot air balloon and the first successful attempt at flight. Over the next few decades, people continued to experiment with various methods of aviation. Slowly, these flying machines began to resemble that will one day evolve into the modern airplane. The brothers are right. Orville and Wilbur Wright were not scientists. In fact, the contraption they knew the most about was a bicycle. But like so many others before them, Orville and Wilbur also were intrigued with the prospect of being able to fly. The Wright brothers wanted to build a plane that could take off from the earth and keep itself flying through the air. They believed that the newly invented gasoline engine would be the key component to their dream of a flying machine. It was December 17, 1903, when the Wright brothers proved their newly created flying machine, called Flyer, onto a North Carolina field overlooking the Atlantic Ocean. The strange-looking contraption had a long pair of wings through the front and a pair of the shorter wings near the rear. The plane also had two propellers that were driven by a single engine. Orville Wright stretched out his stomach upon the lower leg and fired up the engine. As the propellers turned and the plane moved forward on two small wheels, Wilbur ran along, holding the wings to steady the plane. Within moments, the machine was airborne. To their delight, the invention was a success. They made 3 more successful flights that day, though none lasted more than a minute. The Wright brothers continued to modify and experiment with their flying machines. Other people also worked with the Wright brothers. Incredible design, hoping to build bigger, quicker, and better flyers. Over the years that followed, airplanes became more complex and advanced. Even so, all airplanes, no matter how different the size or form, had had some of the basic parts that were on the Wright brothers' first plane: engines and wings. The plane facts. In order to fly, all self-powered planes must have an engine, like the engine of the car. The engine of an airplane moves the airplane forward. All airplanes must also have wings because the wings are the feature that actually lifts the plane into the air. In addition, all airplanes must have parts on their wings that move. These moving parts, called ailerons, help control the plane. Planes have other parts that enable them to fly, and that help pilots control their movements. A plane has a tail section with the rubber that moves right and left. The elevators that move up and down. The pilot is able to determine the movement of these parts with the controls inside the plane's cockpit. Controlling an airplane is almost like controlling a car, except that the pilot has an extra dimension to deal with. When driving a car or riding a bike, the driver or rider can make the vehicle go forward as well as right and left. You can't think of these directions as two dimensions. What's in front of you and what's on either side of you? An airplane, though, can move forward, right to left, as well as up and down. The pilot has the extra dimensions as the space below and above. The plane is in which to move. Controls inside the cockpit how the pilot maneuver through the air in all these dimensions. The cockpit contains several instruments that gives important information to the pilot. The control column is similar to the steering wheel on a car. Turning the column right or left moves the airlines of the wing up or down, which causes the plane to roll side to side. The control column can also be pulled back and be pushed forward, which will move the elevators on the tail up and down. When the elevators go down, the nose of the plane pitches down, and when the elevators go up, the nose of the plane pitches up. Most planes also have pedals that control the rudder. Pushing the right pedal moves the rudder to the right, which makes the nose of the plane yaw right. Pushing the left pedal has the opposite effect, yawing the plane to the left. The big mystery. So now you know how a pilot controls the airplane, but the big question remains, how does an airplane fly? If you compare the wings of different airplanes, you'll notice that no matter to which airplane the wing is attached, all the wings have the same shape. The wing construction is the secret, and the science behind what makes an airplane fly. The upper surface of an airplane's wing is curved, and the bottom surface is flat. This means that the air flowing across the upper surface has a greater distance to travel than the air moving across the lower surface. In order to keep the pace with the air flowing under the wing, the air flowing over the top of the wing must move faster. The faster air moves, and the less pressure is exerts. The slow-moving air beneath the wing exerts greater pressure on the wing's lower surface Then the fast-moving air exerts on the wing's upper surface. The greater wing pressure under the wing pushes the wing upward. This upward push of an air, called lift, causes a plane to leave the ground and fly. Because moving air causes these different air pressures, the airplane forward bottom is critical for it to fly. The forward motion makes the air flow over the plane's wings. That creates the differences in pressure. It creates the lift needed for the plane to overcome gravity. As long as the aircraft's wings keep moving forward fast enough to generate lift, the airplane will remain airborne into the air. As you imagine yourself sitting inside an airplane and gazing at the window, don't think about how heavy the airplane is. Load it down with people and cargo. Instead, notice the shape of the wings and consider the air flowing over them. The Wright brothers did, and because of these speculation and the experimentation with wing shapes and engines, the airplanes of today are able to take us just about any place in the world. Where would you like to go?